I said in the previous video that heat is a form of energy. Newton states that heat is movement of molecules. Before we start, did you ask yourself what is the highest temperature in our universe?
No!
Or what is the lowest temperature?
No!
The highest temperature of our universe was after the Big Bang. It was this large number on the screen. And yes, I am too lazy to say this number. The highest temperature, now also called absolute hot, it's not in the center of supernova or galaxies. The highest temperature was measured here on Earth. Yes, on Earth, in Large Hadron Collider, the temperature reached up to 4 times 10 to the power 12 Celsius. The lowest temperature, also absolute zero, is minus 273,15 Celsius.
But how did we measure this?
Well, by using gas laws, and especially Charles' law, we know that at constant pressure, the volume increases with increasing temperature, and it decreases with decreasing temperature. When we represent this relationship linearly and mathematically in different pressures, we will find that volume will be zero at minus 273,15 Celsius. The lowest natural temperature on Earth is in South Pole. There, it reached a temperature of up to minus 89 Celsius. And the farthest planet from the Sun is Pluto, has minus 235 Celsius. As for the vast deep space, which there is nothing, just emptiness, its temperature reached to minus 270. And the coldest thing in our universe is the Boomerang Nebula, with temperature that reached to minus 272,15, almost absolute zero. Nevertheless, nothing can reach absolute zero. It's impossible to reach absolute zero for many causes. First, it's because of the second and third laws of thermodynamics. These laws briefly say that we cannot make a heat engine that gives 100% efficiency. That means convert the whole heat or internal energy to work without any waste. Uncertainty principle of Heisenberg. This principle states that we cannot determine the position and velocity of an object at the same time. The higher the accuracy to determine the position and velocity of an object, the greater the percentage of errors that will occur. And we know that temperature is the movement of molecules. At absolute zero, the movements of molecules is zero. That means we can determine the position and velocity of an object, and this is just forbidden in physics. In quantum field theory, an object or a particle can't give its 100% energy, and it will always keep a small percentage of energy. And as we know that kinetic energy will never be equal zero. It's true that we will not be able to reach absolute zero, but we can get close to it, and that's what scientists done in laboratories. In 1999, scientists succeeded in cooling radium to 100 picokelvin. Again, in 2018, they set a record by cooling radium to 1 picokelvin, but this time was in a space-based laboratory. However, there's something bizarre, odd, strange
Red sauce.
is happening the closer we approach absolute zero, and I will explain this in the next video. Thanks for watching, see you later.